Welcome back to another Daishinfinity video. In this video, we're going to prove the derivative of the secant hyperbolic of x, which states that the derivative of secant hyperbolic of x is equal to the minus of the secant hyperbolic of x times the tangent of hyperbolic of x. We're going to use the limit definition of the derivative function in order to prove this formula. So let's just dive right in. Now, since we know what the definition of a derivative function is, we're going to write it down as the limit as h approaches 0 of f of x plus h minus f of x all over h. And since we know this, we are just going to plug this in. And since we know the derivative of secant hyperbolic of x is equal to the derivative of the cosine hyperbolic of x inverted or taken to the negative 1 power, it is just equal to 1 over cosh x. So now we're going to plug the 1 over cosh x into the limit, which will be the limit as h approaches 0 of 1 over cosh x plus h minus 1 over cosh x all over h. Now, since we have different denominators, we're just going to cross multiply those two, and then we will get the same denominator over here. So this will be equal to the limit as h approaches 0 of cosh of x minus cosh of x plus h all over the product of those two. So we have the cosh of x plus h times the cosh of x, and that whole thing times h. Now what we can do is we already know what the definition of a derivative for cosh is. The definition of a derivative of cosh, when we are going to write it down, so the derivative of cosh is sinh, whereby it is also the limit as h approaches 0 of cosh of x plus h minus the cosh of x all over h. Now this part is seen over here. So since we have a product, we can factor it out, and then we will have another kind of limit. So over here we will have the limit as h approaches 0 of cosh of x plus h minus cosh of x all over h times 1 over cosh of x plus h times cosh of x. Now, since cosh of x is independent of h, we're just going to put it outside. So we're going to use the limit definition and the properties so that we can write the cosh of x outside. So now we have this, but we want to isolate this, and we have a product of two. Let's say this is a, and let's say this is b. It states that if we have a limit as x approaches a of a times b, or let's say f of x g of x, then it is the limit as x approaches a of f of x times the limit as x approaches a of g of x. So since we have this property of, or principle of this limit, we're just going to write it as follows. We are having the factor 1 over cosh of x in the front times the limit as h approaches 0 of the definition of cosh, and that whole thing divided by h times the limit as h approaches 0 of 1 over cosh of x plus h. Now, if we let h approach 0 here, we are just going to get cosh of x again. And if we look at this is just the definition for the derivative of cosh, which is equal to negative sinh of x. So now let's put this together. So we have 1 over cosh of x times minus sinh of x over 1. Let's just tell it, let's just say it's over 1, and then we have 1 over cosh of x. Now if we take the sinh and the cosh, sinh over cosh is equal to tangent hyperbolic, so we have 1 over cosh of x times minus tangent hyperbolic of x. And now what is 1 over cosh of x? That is equal to secant hyperbolic of x. So we have tangent minus hyperbolic of x times secant hyperbolic of x. And now we have proved this formula, and I really hope you enjoyed this video, and let's see us in another Daishinfinity video with another proof. See ya.